All right, so 3.4a, so the first part of section 3.4, we're going to be graphing rational functions. So last class we talked about asymptotes and how we can find the asymptotes of a rational function. So that's really going to help us be able to find the shape of the graph. So today we're going to take that plus everything else that we know about graphing functions in general to be able to graph these rational functions. So our one learning target for this video is to be able to analyze the graph of a rational function and be able to graph a rational function by hand. Okay? So I guess we have those two learning targets there. So please go ahead and write down those learning targets. Be able to analyze the graph of a rational function, be able to graph a rational function by hand. Okay, so first going to give you the list of steps that we're going to go through, just so that you have them all written down in one place. So the steps for analyzing rational graphs. Please go ahead and write this down. I'll walk through them a little bit, but if you need to pause the video to make sure that you get this written down, please do so. So our first step is that we're going to factor, if it's possible, and find the domain of the rational function so that we know when we graph it what that domain is supposed to look like. Second step is to write the function in lowest terms. Are things going to cancel out? Because we know that we're going to use that later. Third step is to locate the x and y intercepts. So just like when we've graphed in the past, those are two of the easiest points to find on a graph to be able to help us with that shape of the graph and to see where the graph is going to go. So find those x and y intercepts. Number 4, test the graph for symmetry. Now, I still want you to write this down even though it says optional there. I'm making this step optional because you don't necessarily need it, but it is helpful. If you know if the graph has symmetry, then you can use that to find other points. If it doesn't have any symmetry, then that's not really going to be helpful, but if you test it and the graph is symmetrical, then you can find a couple of points on one side and just flip them over that line of symmetry to find points on the other side. Number 5, we're going to locate any vertical asymptotes and holes. So that's what we practiced last class to help us with that shape as well. Number 6, locate any horizontal or oblique asymptotes. Number 7, make a table of points to help with the graphing. So again, we have those asymptotes, we have the x and y intercepts, but then we're just going to try and find a few other points to again help us get that shape of what the graph should look like. Once you have all that, we're going to graph our function by hand, and then use your graphing calculator to check your work. So I've underlined the word check. That's very important. All of this stuff, steps 1 through 7, I'm going to be looking for that on your graph. So I need to see that you found the x, y intercepts and actually plotted them. I need to see that you have put the vertical asymptotes, holes, horizontal, and oblique asymptotes on the graph. And then the table of points, that you found that table of points and that you've actually plotted those on your graph by hand. Then once you have all that, you can use your graphing calculator to check to make sure that shape is correct and that you've got everything. But you cannot just put it in the calculator and sketch it. You got to make sure you show all that work for step 1 through 7 and that's actually plotted on the graph. Okay? All right, so make sure you have all that written down before you move on. All right, so let's do an example. Now, it'd probably be a good idea to use graph paper, at least to graph these. If you do all your work on your other sheet of paper, that's fine. But I would definitely try and have some graph paper handy to do these problems. If you don't have graph paper from the store, you could really quick just go to Google, and if you just Google graph paper, there's a bunch of blank types of graph paper that show up and you can print off a couple of pieces of graph paper. So if you need to do that now, go ahead and do that. All right, so we're going to analyze the graph of f of x equals 2x squared minus 4x minus 6 over x squared minus 9. So we're going to start with that first step. Our first step was to factor it and then find the domain. So this one is factorable. So we're going to go ahead and factor the top, so you can take out the greatest common factor of a 2. And then you're left with x plus 1 x minus 3. Okay, so however you need to factor that. And then the bottom is a difference of perfect squares. So that will be x plus 3, x minus 3. So factor that out, which means our domain, then we know that x cannot be equal to negative 3 and positive 3 because our denominator can't be 0. So since x can't be equal to positive or negative 3, that's going to make our domain from negative infinity to negative 3, negative 3 to 3, and then 3 to infinity. Next step was to write our equation in lowest terms. So check to see if anything cancels out. So here we have an x minus 3 that will cancel out, and we know that we're going to use that later. So our function in lowest terms is going to be 2x plus 1 over x plus 3. Okay. So just write that in lowest terms so we can use that information later. Our third step was to find the x and y intercepts. So let's start with our x-intercepts. So to find the x-intercepts, we're going to plug in 0 for y. So 0 equals 2x plus 1 over x plus 3. And I'm going to go ahead and use the simplified version of this. Okay, so we have, we put our function into lowest terms, 2x plus 1 over x plus 3, which essentially will give us the same shape graph. So we can go ahead and use that to find our intercepts. So we're using our lowest terms function. So plug in 0 for y and solve. So if I can want to cancel out the denominator. So I'm going to multiply by x plus 3 on both sides so that my x plus 3 cancels out here. So x plus 3 times 0 is 0. And then I'm just left with 2 times x plus 1. So I get x, let's see, so 0 is equal to 2x plus 2. So I'm running out of room here. Oh. All right. So we get 0 equals 2x plus 1, negative 2. So x is going to be equal to negative 1. So my x-intercept is going to be negative 1, 0. You can go ahead and put that on your graph as you go if you'd like. So negative 1, 0, I know is going to be my x-intercept. Okay. My y-intercept, we're going to plug in 0 for x. So y is equal to 2 times 0 plus 1 over 0 plus 3. 2 times 1 over 3, so my y-intercept is 2/3. 0, 2/3. Over here, 0, 2/3 is going to be my y-intercept. Right, step 4 was to test for symmetry. This was your optional step, but we're going to go ahead and go through it to see if this graph has any symmetry. So recall that to figure out if a graph has symmetry, we plug in negative x for x into our function. So I'm going to do 2 times negative x. Here, actually, we can go ahead and use our lowest terms again, so we have less that we're plugging into. So 2 times negative x plus 1 over negative x plus 3. So we get negative 2x plus 2 over negative x plus 3. If we were to factor out a negative 1 on both the top and the bottom, we get negative 1 times 2x minus 2 over negative 1 times x minus 3. These cancel out, and you get 2x minus 1 over x minus 3. So this 2 times x minus 1 over x minus 3 is neither the same nor opposite of 2 times x plus 1 over x plus 3 here. Okay, so we didn't have, you didn't plug in negative x and get the same thing, and you didn't plug in negative x and get the opposite. So we have no symmetry. You also could plug it into the original function, but no matter which one you plug it into, you're not going to get any symmetry. So we're not going to be able to use symmetry to find our other points. Okay, so let's keep going through our steps. I'm going to go ahead and put our x and y-intercepts back on here. Okay, so our next step was to find the vertical asymptote and the holes. So remember, the vertical asymptote is anything, any x value that makes your denominator 0, but not the numerator. So in this case, you can see that we have x plus 3 in the denominator. So negative 3 will make our denominator 0. So we have a vertical asymptote at x equals negative 3. So I'm going to go ahead and put that in there. So at negative 3, x equals negative 3, I have a vertical asymptote. So I'm just going to use that dotted line to kind of give me a guide. That guides me to where my graph's going to go. Now, if you go back to when we put our graph into lowest terms, over here we canceled out the x minus 3's. Since those got canceled out, that means that's going to give me a hole at x equals 3. So I have a hole at x equals 3. Now, remember, a hole is just an empty point. It's not a line. So somewhere on the graph, somewhere here at x equals 3, we're going to have a hole. It can be anywhere on the line x equals 3. But since it's just an empty point and not a line, I need to find out specifically where that hole is going to go. So if I want to know, okay, so I know x, somewhere x is 3, there's going to be a hole, but I need to know at which specific y value. Where is that point, where is that empty point going to be that I skip over? So I'm going to take my x equals 3, that hole, and I'm going to plug it into our function. So take 3 and plug it in for x to figure out exactly where that hole is going to sit. So 2 times 4 over 6. So at 4/3. So my hole is going to be at 3 4/3. So we want to find exactly where that hole sits. So at x equals 3 and y equals 1 1/3, there's going to be an empty point there. So the graph will kind of just skip over that point. Okay. Horizontal asymptote or oblique asymptote. So look at your original equation, and we're looking at, for the oblique or horizontal asymptote, we look at the degree of the top function and the degree of the bottom function. So both of them have a degree of 2. So when we have the same degree, we take the leading coefficients and divide them. So I have a horizontal asymptote at y is equal to 2 over 1. Okay, so we have a 1 there. So our horizontal asymptote is at y equals 2. I'm going to go ahead and draw that in there. Kind of gives us an idea of what our shape is going to be for our graph. All right. Next step was to find some test points. So I'm going to look at my graph and I'm just going to pick some x values that I want to test. So I have my x values. I already have a few in there. I have my x and y intercepts. I know where my hole is. So I'm going to want some on either side of my vertical asymptote. Now I don't have any symmetry on this graph, so that doesn't really help me. So what I'm going to do is I'm going to pick 3 or 4 points on the left side of my vertical asymptote and 3 or 4 points on the right side of my vertical asymptote so I can see what that looks like. So I'm going to start with -6. So -6 is over here on the left side of my vertical asymptote. And then I'm just going to go in order. -6, -5, -4. Now -3 has a vertical asymptote. So we know that there are going to be no points on there. The graph cannot cross a vertical asymptote. So I'm going to skip over -3. -2, I already have my y, or my x-intercept at -1, and I already have a point at 0. So let's do 1 and 2 and call it good. See if we can get a good graph from that. All right, so a couple different ways you can plug those points in. Just plug them into your calculator to plug them into either of the lowest terms or the original graph. So just taking -6, plug that into your function for x. Take -6 and plug it into the function for x, you get 3.3. Okay? And that's fine if you want to use your calculator for that. Okay, we have -5. When I plug that into my function for x, I get 4. -4, plug that into my function for x, and I get 6. -2, -2, 1, 1, and 2, I get 1.2. So again, this is just going to give us an idea. Okay. And the last step is to graph it. So I'm going to take those points. So -6, 3.3, so 3 1/3. -5, 4. -3 already has an, or -4, 6. -3 has an asymptote. -2, -2. 1, 1, and 2, 1.2. Okay, so you can see now you know that your graph is going to run along the asymptote and then up. Make sure you have your arrows. And then this graph is going to run along this asymptote. Make sure it skips over the hole and down. Okay, don't forget your arrows. So all those things put together is going to give us that graph. Okay. Kind of clean this up a little bit. So you have all your x-intercepts, you have your horizontal asymptote. Whoa, what was that? It's random. And then just draw your graph based on all those points that you found. All right, so it's a lot of steps. So let's go ahead and try and practice another one. All right, so we're going to do the same thing with f of x equals 3 over x squared minus 4. So again, draw your graph, have some graph paper handy so that we can go through these steps. So step 1, we're going to factor and find the domain of that. So top obviously can't be factored, and we can factor the bottom to x minus 2, x plus 2. This is a difference of perfect squares. So in our domain, we know that x cannot be equal to positive or negative 2. So we can go from negative infinity to -2, -2 to 2, and 2 to infinity. So that's going to be our domain. Nothing in our graph. We can't have any points at -2 or +2. Next step, we want to write our function in lowest terms. In this case, we don't have anything that cancels out in the numerator or the denominator. So lowest terms is just exactly what the original function looks like. Can't cancel anything out. Let's find our x and y intercepts. So x-intercept, we're going to plug in 0 for y. So 0 equals 3 over x minus 2, x plus 2. So I'm going to multiply my whole function by the denominator so that I can cancel it out. So x minus 2, x plus 2 times 0, it's just going to give me 0 on that side, and then my denominator will cancel out. So I get 0 equals 3. Well, since we know 0 does not equal 3, there's no x-intercept. Okay. Our y-intercept, plug in 0 for x, and we get 3 over -2 times 2, so -3/4. So our y-intercept is going to be 0, -3/4. Go ahead and put that there on our graph. Okay, optional step if you want to check for symmetry, so that can help you determine what your graph needs to look like. So we have f of -x, 3 over -x squared minus 4 equals 3. A negative x times a negative x is positive x squared minus 4. So you end up with the same exact function as the original. So that means this is even. So it has symmetry over the y-axis. So that can help us find our points later if we know that our graph needs to be symmetrical over the y-axis. All right, so we got our domain. We have our intercepts, that are one y-intercept that we could use, and we know that our graph has to be symmetrical. So the next step was to find the vertical asymptote and the holes. So we didn't cancel anything out, which means there are no holes. This means we have vertical asymptotes at x equals 2 and x equals -2. So -2 and +2. And those vertical asymptotes, the function cannot cross those vertical asymptotes. No holes because we didn't cancel anything out. Horizontal asymptote. So we have the degree of the top is 0 and the degree of the bottom is 2. So we have a rational function that is bottom heavy. So that's going to give us a horizontal asymptote. And whenever it's bottom heavy, it's always y equals 0. Okay, so if you can't remember that, remember you have that golden half sheet so that you can remember when we have vertical asymptotes, when we have horizontal asymptotes. So if you need a little refresher, make sure to have that golden sheet out in front of you. Okay, so we have a horizontal asymptote at y is equal to 0. So straight through the middle here. Okay. Looking like it has some symmetry over the y-axis already. So let's find some test points. X and y. So pick some points. We know this is going to be symmetrical across the y-axis. So we use that symmetry. So I'm going to pick a few points on the left side of the y-axis and then use symmetry to find the other ones. So let's start with -6, let's say. So -6, I'm going to plug that in for x into my function. So 3 over -6 squared minus 4. Okay, or you can plug that into your calculator and you get 1/10. -5, plug that in and I get 0.14. -4, I get 1/4. Okay. -3, I get 0.6. -2, I already have an asymptote there, so I'll do -1, and you get -1. So I'm going to plot those points. So -6 and 1/10, -5, 0.14, -4 is 1/4. Here, let's try and get these a little closer. -3 is 0.6. -1, -1, -1 here. And then I'm going to use symmetry across the y-axis to find the points on the other side. So +1, -1 will be the same. It's just going to be symmetrical. 3 and 0.6. 4 and 1/4. 0.12 and 0.1. Okay. So to kind of get the shape of this, you know that it's going to follow our asymptotes, and that's going to come up here. This here, again, is going to follow the asymptote, get really close to that asymptote on either side, but follow the curve of those points that you have there. And same with this one. Like now here, you may want to check to see where your where your shape might be. You can put it in the graphing calculator. Remember to check yourself, but you know that it's symmetrical across the y-axis, so it can't go up or do anything like that, because then it's not going to be symmetrical. So in order to have symmetry across the y-axis, you know it's going to follow it always. Anytime you have an asymptote, it's going to follow that asymptote and then come straight back down and follow the other one. So that's where that symmetry comes in handy, to know that, hey, this has to be symmetrical. So I'm going to follow the asymptote on one side, and then it'll come back down and follow the asymptote on the other side. Okay. You know that it can't go up like that because we can't cross a vertical. So actually, nope, I take that back. You can cross a horizontal asymptote. So to double check yourself, plug it in the calculator, see to make sure that you have your shape correct. Okay. So let's go ahead and do that really quick. So if you have your calculator, plug in your function, 3 divided by x squared minus 4, and graph it. You can check the shape of your graph, just like that. Okay? All right, so we will do a little bit more practice with that in class next time, so please come with any questions that you have. If there's any parts in, because there was a lot of steps in there, So if there's any parts to that you had questions about, that you were unsure, please make sure you bring those questions with you to class next time, because we will go through a couple more examples together in class as groups and stuff like that. So one thing that I also am going to ask you to think about before next class, so the only homework essentially that you have to do is try to think of a way to memorize these steps. For a quiz that you may have soon, I will give you the steps for them, but eventually once we test on this, you're going to need to have these steps memorized. You're going to have to know what steps you need to take and in which order to be able to graph this. So students in the past have come up with a mnemonic device. So a mnemonic device is like PEMDAS, where you use please excuse my dear Aunt Sally to try and remember your parentheses, exponents, multiplication, division, addition, subtraction. So you can go through and find keywords in each step. So like the first one, you want to find the domain, so you might use a D. Number 2, we're looking for lowest terms, so maybe an L. X and Y intercepts, so we're looking for in part 3. Symmetry is what we look for in step 4. Vertical asymptotes in step 5. Here you can maybe use 2, since we're looking for horizontal and oblique asymptotes. A table of points is what we want, and then we want to graph it. So your challenge is to come up maybe with a mnemonic device, some words that will help you remember that order, and we'll see what everybody comes up with in class.